Hello, today I'm looking at M3 International A-Level January 2015. This is question 3. So I have a light inextensible string, has one end attached to a fixed point A and the other end attached to a particle P of mass M. An identical string has one end attached to the fixed point B, where B is vertically below A and AB is for little a, and the other end attached to P, as shown in figure 2. The particle is moving in a horizontal circle with constant angular speed omega, with both strings taut and inclined at 30 degrees to the vertical. The tension in the upper string is twice the tension in the lower string. Find omega in terms of A and G. So this is worth 8 marks. So the very first thing that I will draw is a diagram. So what I'm really interested in is what is happening to the forces that are acting on P. So I have the mass is M, so the weight will be mg. I'm given these two tensions. Oops. And it's said that these tensions are along the string which are both inclined at 30 degrees to the vertical. So I know that this angle here is 30, and I know that the angle here is also 30. I'm also told the tension in the upper string is twice the tension in the lower string, so this tension is double this tension. So if the smaller one is called T, the bigger one will be called 2T. Okay, now as well as that, I know that I have the acceleration towards the center of the circle that it's moving in, and I could use v squared over r for that, or I could use r omega squared. Now in this case, because I'm given that some information about omega, I'm going to use this one and not that one. So I have the radius times omega squared. Now I need to just figure out what the radius is. I know that the distance from capital A to capital B is 4a, and I know that this string is identical to this one, and I know that the angles are the same, so therefore I know that the height from the center of this circle to the bottom is 2a. I know that the angle with the vertical is 30, so therefore I know this angle is 30, and therefore I can work out this. If I use tan 30 would be this divided by 2a, so therefore 2a times tan 30 will give me what the radius is. So here the acceleration is 2a tan 30 multiplied by omega squared. Now tan 30 is root 3 over 3. So here I have root 3 over 3, which is tan 30, multiplied by 2a, multiplied by omega squared. Okay, so now I'm ready to do some resolving. So I need omega in terms of a and g. So basically in here I need to eliminate t. So the very first thing that I could do is resolve vertically. In this direction it's not accelerating, so I get 2t cos 30 equals t cos 30 plus mg. So in other words, taking one lot of t cos 30 away from both sides, I end up with t cos 30 is mg. Now cos 30 is root 3 over 2, so therefore I end up with t is 2mg over root 3. Then resolving this way, so I have 2t sine 30 plus t sine 30 will equal the mass times the acceleration. And now this will simplify to 3t sine 30. So I have 3, t is this, sine 30 is a half, okay, so now I can see that I have an m on both sides, so I can get rid of that. I'm trying to get omega squared, so I could divide both sides by 2. If I rearrange this, then I will end up with, sorry, I'm just going to cover this up as I'm finding that a bit confusing there. Okay, so here I'm going to get 3 times 3 is 9, but then I get root 3 times root 3, which gives me a 3 on the bottom. So this, and this combines to just give me a 3 on the top over here. I have a g on the top. This root 3 I already took care of, this and this I already took care of, so I have a 2 on the bottom, and this will end up on the bottom over here. Okay, so then to get what omega is, I just need to square root both sides, and so I get root 3, sorry, the square root of 3g over 2a as my final answer. Okay, I hope you found that solution helpful. Good luck with your studies, and do click like if you like this.